Hey guys, welcome to the last episode of Pre-Calculus on Tuesday, May 12th. Congratulations to all the seniors who are graduating. Our last topic is going to be on mutually exclusive and overlapping events. So it's a little bit more probability, very similar to things we did in geometry. Had we been in class, probably would have made it a little bit more interesting, meaning we had a little bit more toughness to it, okay? And I apologize, I got a little runny nose. We are having a quiz this week. It's the last possible grade, as we have no final exam, or we're not giving a final exam. So that quiz is going to be posted Tuesday evening. We have to have senior grades done by Wednesday, basically, so we're shutting everything down on Wednesday. So you'll have until Wednesday 5 p.m. to get this done, if you're submitting it. All right, I'm going to zoom this in a little bit, okay? Make sure we can see okay. And I'm going to try to focus it. All right, so yesterday we talked about independent and dependent events, where they gave you the word and, which meant to multiply. Well, today we see the word or. And so the or word is going to tell us that we need to be adding. So a little bit different from yesterday. You see the word or, you're going to add. There's two different types of problems. Mutually exclusive problems are when things don't have anything in common. So like, can a fireplace be a dog? Okay, no. Okay, those are mutually exclusive. But over here we have non-mutually exclusive, otherwise known as overlapping events. And so in this case, you talk about a dog, you say, can a dog be male? Well, yes, it can. It can be both male and a dog. But over here, that dog couldn't be a fireplace. So they don't really have anything in common. So that's called mutually exclusive. When things overlap, they have something in common. Okay? So the definitions of those mutually exclusives, the two events cannot happen at the same time. Dog, fireplace, not the same thing. Can't. But in overlapping events, they can happen at the same time. A dog can be male. All right? So here you have dog and a fireplace, and so that they can't have anything in common. However, let's see, grab a good color here. Nope, not that one. A dog and male. Yes, a dog can be male, but a dog can't be a fireplace. So mutually exclusive, overlapping. All right, so let's get into the actual problems. Might want a calculator again, as you're going to be doing probability. So that's what the P stands for, by the way. The probability that we roll 2 dice and get a sum of 4 or a sum of 5. Now, I don't have this prepared, so I'm going to create it real quick. But somewhere, you could probably find this on the internet, is a chart. And you would have had one of these in geometry. 1, 2, 3, 4, 5, 6. So this would be roll number 1. Well, if you roll the die, these are the possible things you could get. You get 1, 2, 3, 4, 5, or 6. If you roll the second die, you could also get a 1, a 2, a 3, 4, a 5, dadgummit, and a 6. Now, if you go back to the problem, it says sum. So we got to add all this up real quick. So 1 plus 1 is 2, 3, 4, 5, 6, 7. So if we roll a 1 and a 6, that sums to be a 7. So So I'm going to alternate some color here. This will be 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And the last row, 7, 8, 9, 10, 11, and 12. All right. So this is where we're going to get our values from, or how many, what's the probability, blah, blah, blah. Okay. So we rolled 2 dice. Okay, that's what we got going on over here. 2 dice have been rolled. What's the probability of rolling a 4 or a 5? So we've got 2 probabilities here. We got to find the probability of getting a 4, and we're going to add it to the probability of rolling a 5. So back to the chart. How many 4s are there? There are 1, 2, 3 4s. So that's 3 out of, y'all know how many there are total? Or there's 6 going this way and 6 going this way. So that's 36 total different sums. 36. We're going to add that to the probability of getting a 5. So there are 1, 2, 3, 4 5s. So that's 4 out of 36. Now, there are 2 different formulas here. One where we just add, and one where we add and then subtract what's called the overlap. So we ask ourselves, can a 4 be a 5? I would say no. Can a dog be male? Yes. Can a dog be a fireplace? No. So if a 4 can't be a 5, then there's no overlap. There's nothing to subtract. So here's pretty simple. 3 plus 4 is 7 out of 36, and that doesn't reduce. So that's the probability of rolling a 4 or a 5. So as we transition over to the next problem, the sum of 4 or an even number. Scoot this up a little bit. Well, we already know what the probability of getting a 4 is, plus the probability of getting an even number. Okay, well, we know the probability of getting a 4 is 3 out of 6. 36, sorry. What's the probability of getting an even value? Okay, well, if you really want to count, there's 18. It's 50-50. There's 36 total. Half of them are even, half of them are odd. So when we do the probability of rolling an even, scoot up, we are looking at 18 out of 36. Now some of you guys are probably going, well, I'm writing down 1 over 2, and that's fine. You can do that. But as I leave it here with common denominators, I can actually add these and not need a calculator. So 3 plus 18 is 21 out of 36. That does reduce. So 3 divides into both of them, 7 and 12. So probability of rolling is incorrect. Forget that. Forgot to subtract the overlap. So we can still use that. We just have to go on and subtract the overlap. So my fault on that. We even talked about it being an overlapping problem. So how many of those even values are 4? So there are 3 of them. So basically what happens, we end up taking out that 3 out of 36, because that was the overlap right here. Sorry about that, guys. And basically what's going to happen is this 3 out of 36 is going to cancel with this 3 out of 36. And so we're going to get rid of this, and we're going to get rid of that. And we're left with 18 out of 36, which eventually is going to be half. That's our answer. Forgot to take out the overlap. My bad. I'm sorry, but I fixed it. So hopefully you're watching the video and not just looking at the notes. All right, so let's talk about excuse me, doubles, and sum is a multiple of 3. All right, so I'm going to move this, kind of shift this up a little bit. All right, so doubles. What does it mean to be doubles? Well, let's see. We want the probability being a double plus the probability of a multiple of 3, and then we're going to subtract the overlap if there is any. Okay, I won't forget it on this one. So doubles. So what's a double? Well, rolling, you can't see it. Rolling a 1 and a 1, that's a double. 2 and a 2, 3 and a 3. So this line of values that come right down through the middle here, these are your doubles. So 2, 4, 6, 8, 10, and 12 are your doubles. So how many doubles are there? 1, 2, 3, 4, 5, 6. So there are 6 out of 36 that are doubles. Okay, in the entire chart, what are your multiples of 3? Well, 3, 6, 9, and 12. Those are your multiples of 3. So how many of them are in this chart? So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 multiples of 3. Now, how many of the doubles are multiple of 3? So that would be the line that comes down through the middle. The 2, 4, 6, 8, 10, and 12. Well, the 6 is a multiple. Oh, you can't see it. I'm sorry. 2, 4, 6, 8, 10, and 12. Those are your doubles. So are any of them multiples of 3? Yes. The 6 and the 12 are multiples of 3. So there are 2 of them. So basically, you can't count the same number twice. So this is our math. So we have 6 plus 12 is 18. Take away 2 is 16 out of 36, which will then reduce. And let's see. 4 goes into both of them, so that will be 4/9, or about 44%. So that's a dice problem. Yesterday we looked at problems that had like marbles and stuff. And so here we have a basket that has 7 oranges and 6 bananas. So 7 and 6, you got 13 total. 13 total pieces of fruit. Trying to get this in there for you guys. Come on. Oh, I'm moving the camera too. There we go. I'm gonna quick move the camera. You have a basket of 7 oranges, 6 bananas. 1 of the oranges and 2 of the bananas are rotten. You randomly select a piece of fruit. Find the probability that it is rotten or an orange. Okay. So probability. Let's see, we're going to do this. Probability that it's rotten plus the probability of an orange minus the overlap. So you got to make sure that you consider the overlap here. All right, you have to remember you got 13 pieces of fruit. All right, what's the probability of something rotten? Well, 1 of the oranges and 2 of the bananas are rotten, so that's 3. 3 pieces of bad fruit. 3 out of 13 are rotten. How many oranges do you have? Total oranges. We have 7 oranges right here. 7 oranges. Plus 7 out of 13 minus. Are there any oranges that are rotten? Yes. There's 1 rotten orange. So we do the addition. 3 plus 7 is 10 minus 1 is 9 out of 13, which is not reduced. And that's our probability of that happening. Okay? So one of the things you'll notice is I really haven't used my calculator, but you are certainly welcome to use your calculator as you're working through these. All right. 2 more problems. All right, so we're drawing deck of cards. Find the probability of the ace or a face card. So ace is not a face card. Face card's not an ace. So this is mutually exclusive. So there's no need to worry about subtracting anything here. So probability of an ace plus probability that there is a face card. I'm just going to use FC. All right. So there are 4 suits. Each suit has an ace. So that's 4. 4 out of 52 cards are aces. Face cards. A face card would be a jack, king, or queen. Cards that actually have a face on them. And so there are 4 suits. There are 3 faces in each suit. So 3 times 4 is 12. Now I said these were mutually exclusive. And so the question is an ace a king? No. Is an ace a jack? No. Is an ace a queen? No. So there's nothing to subtract, like we were subtracting the last few problems. So we'll add that up. That's 16 out of 52, just for the sake of being correct. That is 4 out of 13. So that's the probability of drawing a face or an ace out of a deck. All right, how about a heart or a face card? Okay, so is it possible that a heart can be a face card? Yes. So this is an overlapping probability where we're going to have to subtract the overlap. So probability of a heart plus the probability of a face card, and we're going to have to subtract the overlap in this problem. Let's get this up. All right. There are 4 suits. Each suit has 13 cards. We talked earlier, just a moment ago, that there are 12 face cards in the deck. 12 total face cards. Now what's the overlap? How many of these hearts are face cards? Well, each suit has 3 face cards. So for those of you that don't know, there are 52 cards in the deck. Once you remove the 2 jokers, each suit has 13 cards. There are 4 suits. 13 times 4, 52. And so finally, we're going to add 12 and 13 to get 25. Take away 3 is 22 out of 52. Again, for the sake of being right, 22 out of 52. It's not going to be right there. 22 out of 52 is 11 out of 26. And that's mutually exclusive and overlapping events. Guys, we have one last assignment. It is on a worksheet. Oop, you can't see it. We do have one last assignment. It's on a worksheet, mutually exclusive and overlapping. That worksheet, as well as the key, are already posted. If you need the grade, you may submit that using Remind or email. The quiz will be released tonight about 5 p.m. That'll give you about 24 hours to work on that quiz. There will be no final exam offered, so this is the last assignment. I'd like to thank you guys for hanging with me these last couple of weeks. It's been my pleasure to help you through this difficult situation. And good luck, and I look forward to talking to you soon.